This is Geometry 10.3. We're talking about volumes of cylinders. Recently, we've been talking about volumes of prisms, and that's where the volume is base times height. The capital B implies that it's the area of the base. Sometimes a base can be a triangle, so that base is a different calculation. Sometimes the base can be a rectangle, so that has a different calculation. Now, when we talk about a cylinder, the base is a different shape. What shape do we have for every cylinder's base? Circle. So the area of our circle is pi r squared times the height. That gives us the volume. It's always the same formula. Where the area of a rectangular prism is going to have a different base, and the area of a triangular prism is going to have a different base. So that gets a little trickier, but for a cylinder, we always get pi r squared times h. We already know that h is the height and r is the radius. So the volume is pi r squared times the height. Capital B implies the area of the base. Now, we've done this in the past. We've talked about the exact volume. And here we're defining the exact volume. The exact volume is when we do not round. This means you should leave your answer with the pi symbol. So when we come down here to number 1, we're talking about what is the exact volume of our right cylinder. A right cylinder just means that it stands up straight. It's not slanted, it's not oblique. It's a right cylinder. So we know our volume is pi r squared times the height. We look over here and we see that the radius is 5 and the height is 6. Those are things that you need to recognize from your figure. Sometimes you have to calculate it. Sometimes they give you the diameter instead. So I'm going to take my R and my H and plug it into my formula. So the volume equals pi times 5 squared times 6. So the volume equals 25 times 6, which is 150 pi. Now we could get our calculator. We could figure out what 150 times pi is. But that would be a rounded decimal value. We wanted an exact value. So we're going to call it 150 pi m cubed because this is a three-dimensional value. So we come down to example number 2. It's asking us for the same thing, the exact volume of a right cylinder. So we know that the volume is pi r squared times the height. We know the radius is 6 and the height in this case is 9. So volume equals pi times 6 squared times 9. Well, 6 squared is 36. And I know that 36 times 10 would be 360. So I'm going to do 36 less than 360. 30 less would be 330. 6 more or less would be 324. So you can do some of these calculations without a calculator, but you can also type that in, and that would be feet cubed. 324 feet, or 24 pi. The pi is a very important portion of it. This is not the decimal version. This would be closer to 1,000. But because we're using the pi symbol, it's 324 pi. That gives us the exact value, not a rounded value. And the units are feet. And because we're finding volume, it has to be cubed because we're talking about the number of little cubes that could fit inside of this. What's different about letter B? So with B, we're looking for the diameter. But with our formula, we cannot figure out the diameter. You can figure out the radius, and the radius is half the diameter, so you got to take the radius times 2. That's what we're going to have to do. So we start out, since this is a volume question of a cylinder, we start out with pi r squared times height. Want to be sure that you start out with the formula. Write that first. Now think about what you need to do next. So we know what our height is, and we know what the volume is. Now notice our volume again, it's 200 pi. Don't ignore the pi. The pi is very important. That's not just like a unit, it's like centimeters. This is an important number to our 200. So we have 200 pi equals pi times r squared, because we don't know the radius, times 8. So we're going to divide by 8 pi. Divide by 8 pi. Now, if you were using a calculator, you would need parentheses around many calculators to be able to divide 8 pi. The 8's going to cross off and the pi is going to cross off. Over here, the pi's cross off. We don't need any decimals. The pi's are gone. So really, the only thing you need to test in your calculator is what 200 divided by 8 is. And if you have $200 divided by 8 people, how much would each person get? Get 25. That's what r squared is. But we don't want r squared. So how do we figure out what just r is? Take the square root of that. And how do you take the square root? Or what is the square root of 25? So the radius is 5 by taking the square root of 25. Now, mathematically, it's good to know that when you take the square root of both sides of an equal sign, you get plus or minus. Next year, that's a big deal. You need plus or minus when you take the square root of both sides of an equal sign. But in geometry, we're talking about length, we're talking about a distance, so that's got to be a positive value. So we don't even consider the negative. But mathematically, this would be plus or minus. But since we're talking about the radius, this is a positive value. The diameter is going to be 2 times 5, 2 times the radius, which is 10. So that's 10 centimeters. Be the distance all the way across our cylinder. All right, what makes our next one kind of tricky? What would make the next one easier? What's different about number 3 compared to all the other examples we've had so far?
The answer doesn't have a pi symbol.
Okay, they've done the work, and this doesn't have a pi symbol in there. That you're being very observant. That was great. I was just thinking there wasn't a picture. It really helps when you have the visual. So you can draw in your picture if you like. You have a radius of 6. What we're trying to figure out is what is the height. We don't know what the height of our cylinder is if the total volume is going to be 1253 centimeters cubed. Now notice that the 1253 does not have the pi symbol on it. So when we solve for h, I would expect h to be a decimal that we're going to have to round, because we know pi is part of this calculation. Pi is an irrational number. Pi is going to require crazy decimals. We were able to stay away from that in the previous problem because when we divided by pi, the pi symbols crossed out completely and we were still left with nice clean integers. So we have volume equals pi r squared times height. We know we have 1253 for our volume. We know our radius is 6 squared. What we don't know is what our height is. So we're going to divide. What is 6 squared? 36. So I'm going to divide by 36 and the pi symbol all together. So 36 pi. And I need to do that to both sides. Now, like I said before, we're dividing by more than just 36. We'd probably need parentheses around that. I'll show you with my calculator here in a moment what happens with that. So we divide, and the pi's cross off, the 36's cross off, and I take my calculator, and I have 1253. If I say divided, and I use parentheses to do 36 pi, I get one answer, which seems reasonable. All right, it's much smaller. I'm dividing this by 36 different amounts and then also by the pi. But if I do 1253 and I divide that by 36 pi, I get a different answer. So the parentheses are making a difference. You want to divide by the complete amount. One way you can always work around that is divide by 36, then also divide by pi, and I expect to get 11.07. And we would round that up to 11.08 because the third number is 5 or bigger. And that's height, so it is one-dimensional. It's like a shoestring. It's just a length. It's not an area, so it's squared, and it's definitely not a volume. So it would be 1108 centimeters. Last one. Here's an oblique cylinder. That means it's slanted sideways. Now you have to pay attention to the details you have here. You want to know the exact volume. You know that volume is pi r squared times the height. So we need to know what is the radius and what is the height. Can anyone share what the radius is for this figure? 6 is going to be the radius. The 12 is implying that that goes all the way across. So that's the diameter. Half of the diameter is the radius. So that's going to be 6. So we know that r is going to be 6. What's the height going to be? We have the number 18 here, but 18 is slanted. So the height here, straight up, that's this perpendicular symbol, is recognizing that that is straight up. The height is not 18. We have this triangle that has a 90-degree angle, a 60-degree slant. So the 18 is our hypotenuse. So we've got two ways that we can do this. We could use SOHCAHTOA, or we could use special right triangles for the 30, 60, 90. SOHCAHTOA is going to give us a decimal for our height, which is just fine. But we're looking for an exact answer. And decimal is not going to be an exact answer, so that's not the appropriate way to do it. Does anyone remember the rules of a 30, 60, 90 triangle? Which piece are we going to find first? In a 30, 60, 90 triangle, if we know the hypotenuse, what is the short leg? The rule is hypotenuse equals the leg times 2. So if we have 18, what is the leg going to be timesing 2 to make 18? It's going to be 9. 9 times 2 gives us 18. All right, so how do we figure out the long leg? The long leg equals the short leg times root 3. Here I could have used short instead of just leg, but we're moving on. So that's our short leg. What is the long leg going to be? Nine root 3. 9 times root 3. Short leg is 9 times root 3 gives us the long leg of our right triangle. So now we know what the height is. The height is going to be 9 root 3. Now we can calculate. Volume equals pi. R is 6. So we square that. The height is 9 root 3. So we're doing 36 times 9. Does anyone remember what 36 times 9 is? $324. 324 times pi times root 3. That is our exact value. And these are millimeters cubed, cubic millimeters. Now notice we do not have a decimal. We did not round anything. This is the exact value.